Hello and welcome to Tech Simplified TV and a very warm welcome to the Semiconductor Podcast. We are back with another exciting episode and today with us our esteemed guest, Professor Dr. Bijoy Krishna from IIT Madras. He is the founder and chief investigator of Silicon Photonics in MeitY Center of Excellence, CPPICS. CPPICS stands for Center for Programmable Photonics IC and Systems. So, thank you very much, sir, for accepting our invitation and welcome to TSP.
Thank you so much for considering me in your podcast. It is my pleasure to talk to you, and it would be really good to actually talk something about in which I am passionate about. So, yeah, let's see how it goes.
Yeah, actually, we have a lot of questions because not every day we get to sit with a chief investigator of a center of excellence. So we complain. We as Indian, we complain that we don't have these. We have started late, and at the same time, yes, we should raise our voice that we want this. We want to compete with other countries. At the same time, we must celebrate what we have. We must be proud about what we have achieved. It's our country, our people, and our pride. So let's talk about CPPICS and let's understand what is Silicon Photonics. So, sir, start with your journey, how you started and how you reached to this CPPICS.
Yeah, this is really something. As you started talking about Silicon Photonics, but my research topic not started in the area of Silicon Photonics. Actually, it was started in 1995 to 1996, April 96, be exact. Uh, I was appointed in a project, DRDO project, in electronics and communication engineering, IIT Kharagpur. There is a microelectronics center. That time, that microelectronics center, one of the best place in the country. That was led by Professor S.K. Lahiri. And I was hired there to work on lithium niobate integrated optics. So, lithium niobate integrated optics that time actually considered as a kind of silicon of photonics world, because in lithium niobate, most important component, optical component, that is modulator. Modulator means in which you can encode electrical data into optical carrier, so that you can actually communicate high speed data. And that is how actually in 1980s internet long haul fiber optic communication started. So actually there was a project, DRDO sponsored project given to IIT Kharagpur for making amplifier. So that, because any signal you need to amplify that optical signal to amplify. So though that project was given and a lot of fabrication promise was there, but as you know, in India, manufacturing, fabrication, equipment, lab running, that time it was very difficult, and mostly we were doing some kind of simulation results, and lately we got some equipment and started to fabricate our designed optical amplifier and characterization, etc. So that is how I learned about integrated optics in IIT Kharagpur, and later on I also registered my PhD there in IIT Kharagpur in EC department. However, I was a little bit more ambitious, so I was looking for elsewhere as the project was closing, and PhD was not actually I was enjoying there, because somehow the experimental thing, fabrication, the device implementation, everything what I wanted to do, that was not enough at IIT Kharagpur. And also my main principal investigator supervisor, Professor Lahiri, become deputy director also. He could not give much time to academics. And in the meantime, I got a offer from Germany. So University of Paderborn, Germany, under Professor Wolfgang Solar. So he was that time one of the stalwarts in lithium niobate integrated optics. So more than 40 research scholars was working under him, and that is the lab where first a low loss lithium niobate waveguide could be fabricated, long waveguide could be fabricated, and a lot of nonlinear photonics and modulator lasers, modular laser, a lot of things were getting fabricated. And from there my work was to integrate a laser source, single frequency laser source, which is very important for communication, sensing, a lot of purpose. So that, as you know, any integrated circuits, you need a source first of photonic circuits, source for optical carrier, then you can encode your data, and then you can process optically, and then you can convert back electrical data into optical data into electrical. So that is how it goes. So my PhD topic was single frequency laser development in lithium niobate. I developed there, and I graduated in 2003 April. So then after I went for a postdoctoral fellowship to uh, graduate engineering school in Osaka University in Osaka, Japan, for 6 months. And there also I worked in lithium niobate integrated optics, but a little bit different domain. That group is led by Professor Toshiaki Suhara. He was another stalwart in lithium niobate technology in Japan. So we developed a twin photon pair in lithium niobate. And then after I got another opportunity, my second postdoctoral position in Lehigh University, USA. There also I worked on lithium niobate, and that way it was my lithium niobate journey was going on, only lithium niobate, starting from my IIT Kharagpur, then Germany, Paderborn University, then Osaka University, and then I got offer, as you mentioned, at the US Lehigh University, and they are also working lithium niobate. So it was going on very good. So in the meantime, my target was that whatever I am getting learned abroad, a very good laboratory, I should come back to India uh, to do something differential, okay, to make some change. So my understanding is that in those developed country, you are exposed to very good instrument, very good laboratory, and all resources, everything. But even if I am not there also, those work will continue, someone will be doing there. So but in India, we don't have such facility. We have to create something. Even if I do little bit differential change here, I feel that would be my satisfaction. So as I was thinking that I will be returning back, but my postdoctoral contract in US was for 3 years. Suddenly I got an email from DRDO lab. That time one DRDO lab in Dehradun, that is actually IRD. So there they got also the huge funding to create a facility on lithium niobate technology. Okay, they searched from their NRI talent search scheme. They communicated me and asked me whether I am interested to join there. So that time, I was just completing 6 months, 7 months, or something like that. Mail came, and then I thought that this is a good opportunity. I can work for the country. I can work for DRDO. And at that time, Dr. Abdul Kalam was something role model to everyone. So I thought that if I can get opportunity, I can do like him something. So that was kind of dream. Then I took the offer, and I returned back to my hometown. And so, however, some issues arise because of medical test, a lot of other paperwork, everything. Then almost 5-6 months, it has gone. So I got a little frustrated, and then in the meantime, I again communicated my PhD supervisor in Germany, Professor Wolfgang Solar. So that this is the situation. I came with a great hope, but looks like that it is getting delayed. So whether you have some position there or not. He said that, yes, I am having another position for you. You come, join. I went there. I stayed there another couple of years. And then I got an offer from IIT Madras in 2006. So from 1996 to 2006, 10 years, I was working in lithium niobate. So that time, towards during my third postdoctoral position in Germany, I realized that this lithium niobate is not going to go anywhere, because one reason is that one of my senior actually developed a very good quality mode lock laser, and that time it is the best in the world. And my supervisor and the group wanted to do some kind of transfer of technology to the industry. And one industry came forward, and it was almost agreed for 99%. At the last moment, they actually dropped the idea to transfer of technology. The reason being, they estimated the cost of manufacturing is huge. So that cost may not be actually profitable for them. And so that actually shocked me, that something developed a nice thing, but because of the economy and cost point of view, this is not going to go. So then I just started looking what is the alternative. I am in integrated photonics area, what to do. So that time actually, Silicon Photonics was coming out. Okay. And Intel started investing almost $1 billion in 2000, started working on. And that is because prior to that, in Ghent University, Belgium, one group led by Professor Roel Bates, they worked with close collaboration with iMeitY. Perhaps you know iMeitY in Belgium, right?
Yeah.
And they have developed certain PDK for Silicon Photonics using CMOS foundry, CMOS fabrication process.
Okay.
iMeitY is known for very advanced cutting-edge research for electronics industry. And we started in 2006 the first MPW runs with collaboration with your iMeitY Belgium. And when I got opportunity here in IIT Madras, I proposed that I will start research in Silicon Photonics. And before starting Silicon Photonics, I went to Belgium, that university. I communicated that Professor Roelbaerts, and I stayed there 1 week. I visited iMeitY, and I saw there how the development is happening. And then at the end of the my visit last day, when I was meeting with that professor, and said that I have got an opportunity in IIT Madras, and I am going to start Silicon Photonics afresh from the scratch. So he was a little bit astonished and saying that because he knows about Indian technology, all this type of thing, cutting edge technology, etc. So then he suggested me, better you start some design work there, and we have a software simulator, you can use them and get fabricated, then we can test it here, that is fine. Then I thought that is not my ambition. My ambition is that to do something there, similar type of fabrication process development, and so that our student should get opportunity there. The reason why I actually left India, I want to do something for that, so that our students get opportunity what Western countries, their students are getting those opportunities. Anyway, I came back and started from the scratch working on that. And then from 2006, small project from DIT, DST, DRDO we were getting. And once we started developing technology, also CMOS fabrication process compatible, because my idea is that anything I can do in silicon. So infrastructure is there. So foundry infrastructure is there. So all the photonics devices, if I design and can be fabricated here, that can be translated into foundry, and that can be low cost. For
Mm.
small quantity means cost will be very low. So that was my design. So I was not focusing on any publication much, just to graduate some student, one or two publication or something like that. But mostly I was focusing on technology development. That is how uh, in 2020 I got substantial funding for establishing the Silicon Photonics Center of Excellence at IIT Madras. We named it as a Center for Programmable Photonic Integrated Circuits and Systems because
Mm.
we set out a vision objective for the country for future. So that is how CPPICS came up and established at IIT Madras. I think I have a little bit longish, but I wanted to tell
Oh,
this.
it's amazing story.
Yeah, so this story I need to tell because anything you want to start or do something like that big, you need a lot of tenacity and patience.
Patience.
Yes, yes,
So almost more than 10 years you were working on, not more in publication, rather developing the technology. Then after these long years of
yeah, 14 years.
hard work,
Yes, my first PhD student graduated after 10 years of my job here. So that is how, anything you want to start from the scratch. Most of the time, what happens now, you are under pressure, you are under compulsion that you have to graduate student, your promotion, all the things
um,
here. So I was not caring much about that because I thought that okay, promotion can be 1 year delayed, and I convinced my PhD student, my first couple of PhD student and master student. They were also awesome. They were very hardworking, and I could convince them that at the end of the day you will be awarded. So if you can continue to do work. So that was really very good hard work, and I think that decision what I took that time, it was a good decision in my opinion. Today I understand. Yeah, yeah,
yes. And at the same time, now government is taking a lot of positive steps to promote our
yes,
in-house capability. So that's amazing time for the lab, I would say.
yes,
So you are working on programmable photonics ICs and systems. It's
yeah.
from the name itself, it seems very cutting edge. So can you explain it in simpler words so that if anyone wants to learn a little bit more into it, so can
Yeah.
start from here.
So, this you mean to say that you want to know about why programmable photonic integrated circuits? What is this?
Silicon and photonics, these are two quite, different. For photonics, mostly we know that 3 5 semiconductors are there, compound semiconductors are there. Silicon and photonics, how these two things are merging together, it's
Yeah.
really interesting to know.
Yes. So, when in 1980s, when people used to think about integrated optics, that time people never used to tell about photonics too much. So, integrated optics means they used to think about glass or lithium niobate type ferroelectric crystals or something like that type of material where they can make waveguide, they can make diffractive optics, those type of functionalities. And for those optical properties to harness, you need a laser. And for that purpose, 3 5, as you rightly mentioned, 3 5 semiconductor, which are basically direct band gap semiconductor. These band gap semiconductors are good, efficient for laser diodes or LEDs. So those things basically we used to call that as optoelectronic devices. So optics and optoelectronics, those are the terminology those time actually very popular. People never used to tell something about photonics. Photonics, something it's kind of analogous to electronic, so photonics type of things. Very people used to tell. But as I mentioned, that people were looking for something in silicon because silicon, that is actually the big history for electronics IC.
Hmm.
So electronics IC, that the transistor size when it was first invented, 1947, centimeter size, And then because of the technology advancement and so-called Moore's law, following Moore's law, all those type of things, transistor size was getting reduced and reduced.
Hmm.
However, this transistors, uh, it, later on, you see, you can integrate large number of transistors as you are going for transistor size reduction, right? Because the lithography process, fabrication,
Hmm.
manufacturing,
Hmm.
etc., you can do that. And large number of transistor, if you put together, then you can make your so-called analog circuit, digital circuit, whatever. You can go for microcontroller, microprocessor, and digital electronics. All those type of things you can do that. So it was a high demand in course of time that more number of transistor to come, so that transistor size should be reduced. So again, one more problem came when you reduce the transistor size, the interconnects, electrical interconnects, when you are communicating one transistor to another transistor, that interconnect dimension also needs to be reduced.
Hmm.
So once interconnect dimension you are reducing, size you are reducing, there is a kind of resistance increases.
Hmm.
And then resistance increases again, your because of the density of transistor, your interconnect density also increases.
Hmm.
So when interconnect density increases, then they actually, when you are transmitting any data, they interfere neighboring interconnects also. So that
Hmm.
is fringing
Crosstalk.
capacitance. Fringing capacitance comes. So that is how RC constants actually getting increased. Even though
Hmm.
your transistor size is reducing, you are getting maybe very low, faster switching, low latency within the transistor input to output. But when you communicate one transistor to another transistor, their delay is happening.
Hmm.
That is called electrical interconnect bottleneck.
Hmm.
So people thought how to overcome that. And that is how the idea came. Why not, whenever you want to communicate a little bit longer distance within the chip, then why not converting electrical signal into optical and then transmit optically, and then when in another logic cell, when you need
Hmm. Convert.
you can convert back again. So that is how people started developing waveguide technology, modulator, photodetector in silicon,
Hmm.
so that same CMOS fabrication process you can integrate electronics and photonics. So that is how photonics comes. The silicon electronics and silicon photonics comes. Your question was how the silicon and photonics things. That is how idea came into picture.
Hmm.
And today, what you can see that how it is growing silicon photonics technology. Today, silicon photonics means actually it is a mainstream semiconductor industry. So all big giants, semiconductor big giants, like you start from Intel, IBM, Samsung, everyone, every big industry, even now Nvidia, all those things, they are talking about silicon photonics. So silicon photonics means it is not no more like it is a photonics, it is like a physics subject. It is mainstream technology, not only mainstream technology, it is actually semiconductor technology, silicon photonics. And it is a $1 trillion industry. So that is how silicon photonics is caught up by the industry players, and that is how silicon photonics is popularized, particularly
Hmm.
for that interconnect bottle to overcome interconnect bottleneck. However,
Bottleneck.
some few more challenges are there. People are solving. Intermediately, people are using this silicon photonics transceiver for data center. So data center for handling data, say one rack to another rack, communication, short-haul communication. Say few meters you need communicating. All the copper wires you can just replace by silicon photonic transceiver chip, and that
Okay.
is how it is the main market today. And
Okay.
in course of time, it will be co-integrated together. Some lab level demonstration is there, but it is, I think, in a year or two, you will be seeing that NVIDIA coming out with their GPU-like processor, including silicon photonics co-integration for their AI, ML, all sorts of things they are actually planning. I think hopefully you will be seeing that thing for on-chip
Okay.
co-integration.
Okay.
Electronics are, it means on chip though, of course, but on chip That means what I mean to say, co-integration of electronics and photonics in a single chip, same process line.
Okay.
Yeah.
So research is in very fast pace. At the same time, I mean, the market level will get the chip on market within coming few years. That
No,
breakthrough is very near.
no.
In case of
Actually,
GPU and as you said, that
right,
main trend.
exactly,
Right
exactly.
now it's in you these things are getting used in data center. No.
Mostly, currently, major market is data center markets, and few other markets are there, but very small volume.
Okay. So
Hmm.
just I mean, as I'm talking, a question raised in my mind that since it's using silicon photonics, wares are removed. So in any way, heat generation issue is less in case of photonics, silicon photonics. The heat generation is a big problem for data center.
Correct. So this is what in data center, heat generation and power consumption basically. Uh,
Yes.
that actually is a huge problem. So sometimes I can remember someone was saying that the way data centers are operating and the data demand of data is coming up. That maybe I'm talking about 10, 20 years ago. So the thing is that the power required to drive a data center, like Google, Facebook, all those type of data centers, if you run, you may need a nuclear power plant just beside a data center. Such a huge amount of power requirement was
Hmm.
there. So that is how the silicon photonics research actually accelerated. So where actually the power consumption reduces a lot. Okay. So because this copper wire, you cannot just go for long distance and heat generation, as you rightly mentioned. That is a waste, a lot of things. But
Hmm.
here, little amount of energy will be consumed per bit transmission. Maybe you can go to, people are talking about femtojoule per bit transmission. So that is how actually silicon photonics playing a major role. Yeah.
Okay. So I mean, so as you said that doing something, developing a system, a technology at own country, in your own country, that actually triggered the arts to develop
Correct.
establishment of CPPICS.
Correct. Correct.
And what is the main goal or vision when you thought that I mean,
Yes. So
only
that
research or integration with industry? What
no.
is your main goal?
The idea is following. So, when we started this Center of Excellence here in IIT Madras, so we explored, and I found that this transceiver market is the only market that time. And Intel, Cisco, they are actually going in a big way, and their investment is a huge. Okay? So if I start something here in the same line, just to solve transceiver, I think we have to compete with those giants, right? So that is actually will not be able to make it proper impact, because the level of investment, their investment or whatever things, and we cannot compete really. So I thought that since it is a silicon photonics, and since it is a CMOS compatible fabrication process, and all the photonics devices design is actually CMOS compatible design, so I could see that many more applications can come up besides your data center applications. So people were already that time exploring about quantum photonic processor and neuromorphic computing and LiDAR applications, and of course microphotonic applications for 5G, 6G usages. So we thought that we'll be going for something which is emerging, so that
Hmm.
world also starting and I will be starting, so that we can compete, and probably we will be able to at least one or two product will come up where we will be at per global scenario. So
Hmm.
that was idea. That was the idea. We thought that transceiver things, although you know that all the components required for transceiver, if you go for some other applications, you need many other device design, many other device integrations, all those type of things. So that many challenges are there. So we thought that those challenges we should take up and solve something for the country. So that country, because our intention is that this center should be something they kind of should follow a model where you can go for kind of product research and product research development and manufacturing model. So identify a product. For that product, whatever things are required, you design all those components and circuit, and then you go for manufacturing, you can go for system level applications. So that is our vision objective set. So that is how we have. Yeah.
So MeitY and government of India, their goal is to achieving self-reliance in technology field. So this lab is, I mean, is a aligned, completely aligned with the same thought.
Correct.
So
yeah, you are right that because you know that I think at least I see that present government, the policy, they want to have some kind of, you know, all these slogans, make in India and digital India, all those type of things. So those type of things actually make sense that something one day we should be proud for having some kind of products actually coming out from India and ruling globally.
yes,
Anywhere you go outside India, you see that I hardly find anything that coming out of India, any product in the market. You can get a lot of Chinese product, a lot of other country product, and India actually basically consuming mostly.
exactly.
Whatever people are doing, we are consuming.
We have a huge market, yet we are consuming, and that money is going to other country. If we can, for domestic demand also, we can do something. Just think how many. I mean, that money will be. We don't have to. That money will not go to some other country. That will be really good.
Correct.
And
I think you see, this is, I have some analysis on that. A lot of people are saying like that something you should uh, look for our domestic market, so that domestic requirement instead of procuring from outside. That is actually true in one sense. I think the today's scenario actually it is very difficult that you can everything you can produce in India for a certain product or anything in India and use it. So you have to rely on many other supply chain and many other country product. For example, if you see that this lithography tool, for example, UV or whatever, the only one country, that is the Netherlands, that ASML, they are actually ASML is manufacturing the best quality lithography tool, right? EUV lithography, UV lithography. So whole world is relying on that. So you need to be dependent on many other things, but at least world should be also dependent on India bit. So that is
yes,
the target you should focus for. It is not that India needs to be completely independent. Everything will be done here. Not necessary. At least I want to see world should be also dependent on India in some way, right? So, in my opinion, if you see in current scenario or maybe something, if India is not completely blocking whole world will survive. But India will not survive if India is blocked by outside country. But what you do, you make them also independent, dependent on India. Then they cannot block you because they will be also
exactly.
right. So that is how my thought process goes. Actually, we should do
Equal dependency. We
correct.
could.
Otherwise, you have to depend on others.
Mm.
It is not the one way process.
Yeah.
Yeah, yeah, right.
You know, Nitin Dahad, he is the editor in chief of E Times. I have
Mm-hmm.
interviewed him. So he
Mm.
said, Munmun, in Silicon Valley or elsewhere, people think that that brilliant brain, mind that coming out from India, they are absolutely brilliant. They are fabulous. Always eager to hire them, although they don't have the same, idea about products that's coming out of the country.
Correct.
Minds
Yeah,
are brilliant. They will come to our facility and make brilliant things. Although the
yes.
things that's coming out from India, the country, no, 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 not
Only
that.
only best minds they are getting. If all companies, all industry, big industry, if you see that, I think there are good amount of Indian talents are there, and they are
Yeah,
contributing.
everywhere.
That's true. That's a
Look,
that's
E Times, their editor in chief is basically from Indian origin. He is Indian British,
okay.
staying in London, and he is Indian from Rajasthan, I
Right.
guess.
Yeah.
So, editor in chief, and his teammates are basically from other countries. So,
Yeah.
everywhere, Indians are everywhere doing good, really good. And although the products we are making here don't getting that kind of uh, attention, or probably we could not making such things. We
No
have to.
problem. So I have something to say here. You know, most of the time I see many of the review committee I go and I listen that India should produce something to actually pluck some low hanging fruits. Okay, so low hanging fruits if you target, excuse me, thing is that there are low hanging, because it is low hanging, anyone can do anytime. Okay, so after one or two sales, maybe somewhere else, some maybe China or somewhere, they will be also developing that low hanging fruits, and they will be giving you cheaper cost. No one will ask to buy from you. Even something you manufacture here, if same quality, if you get, China is giving same quality cheaper price, you will not buy. I think patriotism will not work there, because people will be thinking about cost first. Their
Saving
bread and
money.
butter, that's the major thing, so they will be going for that. So I always think that you have to deep dive. I think thing is that you have to deep dive into the ocean, deep inside, so that your competitor will be minimum. Okay.
Hmm.
So, and thing is that if you want to produce something, it has to be world class, best quality,
Hmm.
and of course low cost. So then low cost you should try, but best quality, little bit higher price also, it is okay. People will be, because it is little bit best quality and
Hmm.
but best thing is that you make. My slogan is that make best quality and low price. Then only you will be able to survive, and you can actually compete. You can exist. You can survive. So
Hmm.
that is how one should think about. Not only for, that's why I never think about something to do research only for Indian demand. I think about, you look for global things,
Hmm. Hmm.
manufacture, make in India, but outreach to the you just compete globally. Then if
Okay.
something comes, even if it is one product comes, that would be my success. That is how
Yeah.
I look for. Yeah.
Okay. So, apart from programmable photonics ICs, what kind of other research work is getting done in CPPICS?
Yeah, that's a nice question. So actually, one day one of my friend from DRDO, I was meeting him about 10 years later. Okay, so he was asking me that, hey Bijoy, you are still working in Silicon Photonics? He was just a little bit talking like that thing, as if I have nothing to do anything else then. So I thought, yes, I'm still doing Silicon Photonics, because there is plenty of challenges to solve there, and I'm getting a lot of problems there. Why should I do something else? Okay, So actually, this is the right question to answer for me, because it is something. It is from the core of my heart. I believe that if you want to do something good, you need to work in a certain area for a long time. Failure will come. If failure comes suddenly, if you just move around somewhere else, some other technology you grab, then you
Hmm.
are diffuse. Then you will be always everywhere in the shallow level. Okay, so you cannot go inside. So I thought that since Silicon Photonics is here for a year, it will stay for this couple of decades more, or maybe century. So I thought that I will be only focusing on Silicon Photonics, and Silicon Photonics. I think you have plenty of problem to solve, and I am only working on Silicon Photonics. And only one thing is that not just like producing papers or something like that. No, so it is like a product research development and manufacturing model. We identify certain products and we are working around that thing. So that is what we are doing. But of course, what we do, not only that, we are working only for our own vision and mission, since we have created certain facility, right? And that is a government public funded money, right? So what we do that we also plan for, we have already planned, and we are also servicing also, if anyone comes to test from our facility. We have a very world class facility, test facility we have created here in CPPICS. Like we can do wafer level testing, automated testing setup. It is industry standard, and we are developing also packaging, all those type of things. Those type of things, if anyone wants to do uh, from their own design, own chip, and they want to get it done from our lab, we can give their support. But normally to run this facility, we will be it is kind of pay and use type things. So you can pay and you can use. Facility is there. The operator, the cost you have to pay. Yeah. So that is how we are offering. Yeah. So
Okay.
people can do sensing, sensor related research, can data center related research, all those type of things, and they can get a service available from CPPICS. So those type of things we are doing. But our core research is only certain product development.
Okay. So microwave photonics, quantum photonics, these are also part of
Correct.
the work.
Yeah. So we are basically targeting, as I mentioned, not data center means what. So we are doing, for example, microwave photonics processor and quantum photonic processor. So those are the processor. Also globally, many startup, many industry also doing that thing. So we are working certain applications, targeted application, like microwave photonic transreceived module and microwave photonic beamformer. So those are actually 5G, 6G application area, and kind of quantum photonics related things. We are developing something called multi-protocol quantum key distribution transceiver. The same chip, you can have multiple protocol you can implement there for secure communication, key distribution purpose. And also we are developing a boson sampling processor. This is another variation of quantum photonic processor, where we have designed for 8-mode boson sampling processor. So those things in the line we are doing, we are working on it. Yeah,
Boson means
boson means photon basically. So
yes, by Bose-Einstein theory, that thing
correct,
bosons, the
correct.
particles named as bosons, right?
Because the boson sampling, the name comes because the particle which follows Bose-Einstein statistics. Uh,
Yes.
Photons also follow that thing, so that's why it is named after kind of boson sampling. But we are using photons basically. Yeah.
We always get pride in bosons because
Yes, yes,
that was
yes.
this
Uh,
by
Correct. Yeah. So I always say that normally in science and engineering, any book or any technology you read, uh, something actually were coming from our own country, India, right? That is actually two. One is boson, Another, you know what? Another is Raman effect. So these are the two things actually you can get in the kind of bibliography or were actually regularly used in scientific research and journals. All those type of things, we get proud of it. Yeah, really.
Yeah, obviously. I mean, you are doing the research. So, already any photonic device or circuit you have developed in the lab? Any patent?
Yes. So already, you know, our this CPIC center actually completed 4 years, and that's a obvious question you will be asking. I know that what sort of product you have developed so far. You know, very
So,
recent.
because development is a core theme
Correct.
in
Yeah.
your work, you are very focused on development. So,
Correct.
that's why.
So recently we have developed a quantum random number generator. Okay, that chip scale quantum random number generator, and that chip is designed by our research scholars, and it is manufactured here. Also, it has been the design is such that you can manufacture in foundry also, commercial foundry,
Okay.
and that is packaged, and module also developed, and it has been one copy, one module is going to be delivered to DRDO on 27th of this month, 27th May, just 1 week from today. And another module we are going to launch for use case purpose on 2nd of May, and our Honorable Secretary MeitY, Sri S. Krishnan, is coming to launch that on 2nd of May, and it will be launched from our neighboring society here, one of the organization, Security Society for Electronics Transaction and Security, called SETS.
Okay.
Society for Electronic Transaction and Security. So they are one of our colleague, is our collaborator, and they are putting that our QRNG module for in their server, so that many customers they can use it for their different type of applications, particularly for OTP generation and banking, financial, all those type of purpose. It will be used, and that is going to be launched on 2nd May. I'm just disclosing here, and
Great news.
to see that on 2nd May. Yeah. Yeah. So that is
Hope we
one.
get
Uh,
hope we get to see some that
yes.
inauguration ceremony or whatever the official ceremony, some pictures in LinkedIn. So if there is something, no, if there is no problem sharing things, so please share in LinkedIn. We would love to
Yeah,
see
no, that
the.
normally whenever we do something, we develop something, we are not shy out of it. We normally put up in LinkedIn and we put up in our website.
Please.
You will be able to see. Yeah, so that is there. And another product, you know, one of the major hurdle for photonics chip, you know, worldwide, it is the photonics chip you fabricate. In the photonic chip, you need to package it. It is not like a conventional packaging like electronic IC. In
Mm-hmm.
electronic IC, you have transistors and all those type of things, and you need only electrical connections. But in photonics chip, you need a optical attachment also, fiber array attachment. And in our center, we have developed fiber array unit attachment tool. Okay, so that tool is also we are installing in our packaging partner, iZMO Microsystems in Bangalore.
Mm-hmm.
So that is also going to be, that entire setup tool will be installed there, and that will be dedicated for regular packaging purpose. That will be also inaugurated by our Honorable Secretary S. Krishnan on 2nd May. So that is, these are the two things currently we have. And you also asked about patents, and so we have already generated two. We have already two US patents already granted, and couple of Indian patents already filed, and three more patents are filing process. So patents are also we are doing, because ultimately, you know, patents is very important, because as you know, not only manufacturing something like that, we are also interested to go for incubating a startup also, so that the startup can translate for mass scale manufacturing or whatever demand is required, they can at least scale it up. So we are also working in that direction as well. Yeah. So yeah.
Okay. You visited the iZMO's facility, packaging facility. That picture came out in the LinkedIn. The
So that
ST scientist, E-level scientist, Dr. Shankhadeep Das was also probably with you in that
yeah.
tour, lab tour. The pictures were in LinkedIn. Yes, I saw it. iZMO
So
Microsystems.
that time that photograph was taken because Dr. Shankhadeep Das also together with me, also together
Yeah.
we visited inside. So there was a meeting was happening, high level meeting for something related to transfer of technologies. That's why
Hmm.
he was there. But we have been working with ISMO for last 4.5 years, more than around 5 years. Okay,
Okay.
so really tight collaboration we are doing, because ISMO, in Bangalore, they have a very good IC packaging facility, but they don't have photonics chip packaging facility like fiber attachment facility. So that is where we are contributing together. So photonics chip, when it is developed, they are actually putting in the package all the electrical connections, DC, RF connections they are doing, and we are attaching the fiber, and that is how packaged module, for example, QRNG module came up like this. Now this packaging fiber attachment tool is also going to be installed there, so they can do entire packaging things are there. So they are a very good partner, and they are also ISMO Microsystems. Actually, S12 it name was SI2 Microsystems. So they are with this center from the beginning, and uh, and they are contributing a lot. That is actually a huge uh, impact, and they are also very passionate something to make in India to go for that type of thing. So they are very complimentary work, helping
Hmm.
us. Right?
It's a very good industry and research
Correct.
collaboration. Very
Correct.
good collaboration. Actually, this kind of collaboration is very much required. There should be a seamless connection between research,
Yeah.
industry, marketing the product, and the research which is going on in the lab. Dr. Mary Haley came and she said, from Finland, she said that many products we at lab we say it's very good. When it comes to implementation, as you said about your first technology thing about lithium thing, that
Correct.
it's not viable because of cost.
Correct.
Profit will not come.
Correct. Correct.
So cost is a big thing in business. So that if that balance is there and every time this knowledge exchange is there, so research will be in very readily acceptable. The things will readily acceptable in industry and mass production could be there. So it's a very good thing.
Correct. This is a very valid point, because even though you in the lab level you use a very good equipment and a lot of
Hmm.
time you spend patiently, and then you develop a prototype. But ultimately, after developing prototype, you have to look for that. Okay, tomorrow if thousands of module require, how to manufacture them, how to scale it
Hmm.
up. Cost should not be very high. So all those
Hmm.
types. So CPICS is closely working on that. Not only the product related research and development, also entire supply chain. So for the scaling up, for example, we have collaborated very strategically. Because we have the capacity of designing photonics chip and small scale fabrication in house, but ultimately to go for a product you need packaging,
Hmm.
and you need actually commercial foundry for mass scale manufacturing also. Otherwise,
Hmm.
costs go up. Lab level you cannot manufacture, and you can go to the market, right?
Hmm.
So all those type of things we are looking into that, and entire ecosystem development, value chain development, everything we are working accordingly. And the thing is that wherever we are doing any collaboration or things, this is not one way collaboration. one-way collaboration never last long, right?
Mm.
So
Yes.
people, you can help me once, twice, third time you say that sorry. Yeah. So
Mm.
that we are actually collaborating the people whom we can also help.
Exactly.
So iZMO Microsystem, they have electronic packaging facility, but they don't have fiber attachment facility. So we develop that. We are giving them. So it is kind
Mm.
of, they are also dependent on me. We are also dependent on them. So this type of dependency, as I was always thinking that this collaboration means you have to have some kind of complementary collaboration where you need.
ISMO and CPICS both are bringing something to the table, so it's
So our research scholars
two way.
go, our research scholar freely goes to them and work with their engineers and help them, learn from them, and come back and what is requirement, packaging design rule development, and then trial and error, how it is going, yield, and agility test, all those type of things we are doing in day by day to day.
It's it, it's a
Yeah.
kind of cohort. I
Yes.
mean,
Yes. Yes. Very much. Yeah.
and this Silicon Photonics is, since it's compatible with existing CMOS technology, so it's really scalable, and
Yes.
industry is keen to
Yes.
develop it.
Correct.
So, what are the education and training facilities are available in CPICS other than
You see, it
BTech,
is.
MTech research or what?
You see, this is our CPICS is a kind of, as I mentioned, it is a product research development and manufacturing model. It is following that model, right? So definitely we have a lot of training process happening because
Okay.
we entire center is running by our PhD student, MS students, MS PhD research scholars, postdocs, and also UG PG students. They also do their project work.
Mm.
Internship we can offer, and time to time we also conduct some kind of workshop, short-term course training. So those type of things are there, and definitely people can learn. If they want, they can write to us. They can come and stay here and see our lab facility, learn a bit. That is always there, and
Okay.
also a certain course also we have developed. Some NPTEL course I have developed also. People can also go through that also.
Okay. So you are, I mean, in NPTEL course is also there.
Yes,
NPTEL
yes.
course is really good, very good.
I have
I
a
mean,
integrated photonic devices and circuits. One course is there, and that was a very good content, I would say. But how good I deliver, I don't know. But it is available in the NPTEL, and you can just direct if anyone interested on that. Yeah.
okay, sure, sir. And one thing, when we started Tech Simplified TV, our inspiration was NPTEL videos, because in early days there was nothing. We
Correct.
only had support of NPTEL videos. We used to watch when we joined industry or doing research. That time we used to watch NPTEL videos a lot. So that is our inspiration to making video tutorial and all. So it's, we are really grateful
Yeah,
for
yeah,
NPTEL videos and IIT professors.
yeah,
And
yeah. There are a
sir,
lot of
this research, yes, sir. So many professors are contributing, I know. And research activities, these research activities are interdisciplinary, like, I mean, electronics, physics, from both field they can join, or
again, you see, it is very much interdisciplinary because
hmm,
again, I am saying that the anything you go for a product, right? So
hmm,
we say that silicon photonics, but silicon photonics is a chip, okay? And the silicon photonics, the one part is that the photonics itself you cannot control. It is photonic circuit means you can control photon flow, right? Photonic circuit, like electronic circuit, you can control electron flow.
hmm,
That is
hmm.
how circuit you get. And photon flow means that photon generation. That is again you can call it optoelectronics you mentioned, right? And then that is how you can get laser carrier, light carrier, right? And then you need a electrical signal to control, switch, route the optical signal on chip, right? And then you need to again convert optical signal into
Electrical.
electrical signal. You need a photo detector. That is again optoelectronics. Okay.
Hmm.
And then that is actually chip. Chip itself is a interdisciplinary things. Silicon photonics technology itself is interdisciplinary things. You need electronic device understanding. You need how the electronic circuit works and how you can use them to control your photonic integrated circuits. All those things required. That is interdisciplinary. And then if you talk about product means packaging. So there you need all sorts of chemistry, mechanical engineering,
Mm,
thermodynamics, all those type of things you need, right?
everything.
And then reliability testing, etc. So it is very much interdisciplinary. So it is very much interdisciplinary. But thing is that one advantage is that so all those infrastructure is available, right? Expertise are available. Only silicon photonics technology expertise are not many are there in the country. So that is the part we are feeling, and we are taking all other experts organically. Whenever something needed, we are just approaching them. Hey, we need this type of expertise from you. Will you be able to help? If someone is interested, we just call them and then we work with them and then develop the product. So it is very much interdisciplinary. Yeah.
Okay. So this programmable photonics is also part of quantum computing. So,
Correct.
so is there anything you are doing related to quantum computing, and
Yes.
any
So
work is getting done?
So I think let me clarify what is programmable photonics.
Mhm.
Okay. So you perhaps know that when we talk about CPU or GPU for computation purpose,
Mhm.
you need a kind of mathematical algorithm, and you
Mhm.
need a program, and then you can get certain kind of work done out of it. Correct? Similarly, this photonic integrated circuits also, you can design a photonic integrated circuit where you can implement a program to get a certain task. Okay. So, for example, you need some kind of operation, say some kind of filtering applications, or you
Mhm.
want to do some kind of qubit generation, quantum bit generation, and you want to do some kind of entanglement, and you need sometimes some kind of superposition, quantum superposition, everything. So you can have certain kind of circuits, and you can reconfigure your circuits program to work in a certain way so that you can achieve certain functions. So basically, that is the idea we have taken from that. Okay, programmable electronics are there like FPGA, field programmable uh, gate array, right? FPGA.
Mhm. Mhm.
Here also we can think of a circuit design which can be programmed for certain quantum function, even quantum photonic processor also, like boson sampling processor I was talking. That is also needed a programmable photonics. Okay, so you need to program certain building blocks to achieve certain applications, and if you want some other functions, then you can reconfigure it. That is how we call
Okay.
it programmable.
A
So that
parallel of FPGA in photonics.
it is not exactly parallel. I must clarify to the audience. This it's a kind of FPGA is used for kind of digital electronics programming, right?
Yes.
Gate
Yes.
operation and different type of things. But programmable photonic circuits, it is not a digital. It is a kind of analog operations. You can just switch program for analog function. All
Okay.
photonic integrated circuit today, they work like a analog way, not like a digital way what FPGA does. Okay, so this is the difference. But still, function operation principle point of view, it is almost similar. That's why you call it as a programmable photonic integrated circuit.
Okay. Uh, all these is this silicon photonics is, I mean, environmentally sustainable and reduces ecological impact compared to the existing one.
You say any technology, I think it is very easy to say that environmentally stable or ecologically viable, all those type of thing is there. but ultimately at the end of the day, it will be manufactured in commercial CMOS foundry.
Hmm.
So if you can think that this foundry is ecologically viable and stable, everything, then Silicon Photonics is there. That is the thing.
Okay.
As you can think of that, the Silicon Photonics is coming up and very fast space. It is progressing because of three reasons. First thing is that it can consume low power, energy efficient.
Mm-hmm.
And second thing is that you can operate things with a very high speed, switching high speed bandwidth is there. And third thing is that capacity utilization. So that means what is existing infrastructure that is being utilized. So all these things, it is kind of capacity utilization means you are not making any extra impact
Hmm.
to the environment. You are not making any extra impact to the ecosystem. Okay, whatever existing, you are using that capacity.
Hmm.
So you are not bringing any extra burden for sure.
Okay.
Okay,
Yes,
yeah,
and energy efficient also.
correct.
So there is a collaboration with SilTerra from Malaysia. It's mentioned in your website also.
Yes.
So which kind of collab is there? I mean, what kind of international collaboration is going on?
So, this is a very important collaboration between us, between SilTerra and us. One thing, as I mentioned, that we have started our Center for Programmable Photonic Integrated Circuits and System with a in-house fabrication facility with 4-inch
Hmm.
wafers.
Hmm.
Okay, so we could fabricate component level, design components and fabricate here, test here. We started doing that thing. As I mentioned, at the end of the day, your device need to be manufactured in a commercial foundry. Otherwise, your cost will not be uh, slashing down, right? It will
Hmm.
not be
Hmm.
reduced.
Hmm.
So what we do that and another thing also, Silicon Photonics is all the photonic integrated circuit, whether you call it programmable photonic integrated circuits or whatever, they are not, they're actually operationally or circuit point of view, uh, it's very much different than your electronic integrated circuit. In electronic integrated circuit, you have only one transistor. If
Hmm.
you just design, model, and then you can design entire circuit. Transistor is the basic building block. Photonic integrated circuit, you don't have such a basic building block. So you need many components for any particular productive things. Hundreds of components may be required. Okay, you don't have like a fundamental building block like a transistor type things.
Hmm.
So that build circuit. So many new products, new applications, you need many new type of device design. So we do design such that it can be manufactured in a commercial foundry. And India is not having any commercial foundry yet. So that's why India semiconductor missions, all those type of things are happening so that all the foundry comes. So we don't have such foundry. So we initially, when India semiconductor mission was announced, then I thought that since we don't have any foundry, why not doing something a R&D mini foundry at IIT Madras? I discussed with our director. Director said that yes, if you can bring fund, we can give you land, 50,000 square feet land also already allocated, and he committed also that electricity, water supply, whatever required, we will be giving. Okay, so then I thought that to do that, at least I have to talk to a foundry. Okay, I need to visit a foundry and I need to get their opinion of how to do that. So that is how I communicated to SilTerra Malaysia. Okay,
Okay.
so they have a very good silicon photonics fabrication process.
Okay.
So 8-inch wafer process lines, and even I make a whole world, a lot of startup company they are using their fabrication process.
Even
So
I
when
make.
I make also, yes, I make whenever they are overloaded, they outsource here. They have a very
Wow.
good fabrication process. Yes, yes, that is true. No one, many people not knowing that. Yeah, that is correct.
Exactly.
Yes. And then when I talk to them, they say that we do have only fabrication process, because I had to tell them that what I want. I told them initially that, okay, I need some kind of, we have a lot of new device design that is CMOS compatible, whether that can be fabricated or everything. We want to check it. So they say that that time they wanted to, they are selling their fabrication process. Anyone can go and fabricate with their own PDKs,
Mm-hmm.
right? They wanted to also go into that PDK business also. So they that say that, okay, let's do one thing. We can have a kind of collaboration with mutual benefit. You help us developing PDK, and we will fabricate your all the components, devices in the foundry. That is how collaboration, again 50-50 collaboration, right? We are contributing to them, and they are actually also helping us. So that is how we have access to the foundry, we have access to the packaging industry. So that is the entire, as I mentioned, that entire supply chain is required, no? So we have the design and test facility, world class test facility, and we have the world class packaging facility being developed with iZMO Microsystems, and we have world class foundry collaborator SilTerra is there. So if we have some idea, our research scholar, our new generation, if they come up with the idea and something is being generated in our CPPICS, that can see the market directly
Great.
if it is developed in a systematic way. So we have the entire supply chain. So that is how it is there. In fact, again, 2nd May, this our SilTerra colleagues will be coming here also. We will have a
Okay.
mini workshop, and they will be joining actually. Yeah.
Okay. So you are
So,
having some inland and international
yes. So actually, again,
collaboration, great collaboration.
and also another thing I should mention that for our audience, when we do collaboration, we don't go collaboration where we cannot really help others, right? As I
Mm.
mentioned, so we go we find a collaboration where actually we can complement to each other. Okay, so that is how our collaboration is growing. Many, I am also in touch with many of our European colleagues and American colleagues also. But it's kind of thing is that we are exchanging ideas, all those type of thing, but not in real time collaboration. So our real-time collaboration is actually international, like Malaysia, SilTerra Foundry, and then our very own iZMO Microsystem in Bangalore. That is
Okay.
that is our collaboration. Of course, we have also collaborated one more international multinational company. Keysight. Keysight,
Keysight,
right?
yes, yes, yes.
We are also developing compact models for photonic circuits and for EPDA development, electronic photonic design automation, like EDA in electronics, electronic design automation, EPDA development, and we have developed few compact models, and we have delivered to Keysight, and they have already launched in their product also. And second phase we are
Okay.
also working on them. Yeah. So those type of things are there. That is actually kind of Keysight is our client, for example, you can say that type of things.
Okay.
Yes. Yes.
So actually, your lab students from your lab or researcher from your lab, they are working with Keysight engineers
This
to.
I must mention that not only our research scholars, my colleagues also, as I mentioned now, where I am not expert, particularly compact modeling. We have a very good colleague here who does compact modeling for electronic devices, but he does not understand photonics. So we
Okay.
had several round of discussion with him, because we should understand each other's language, right? So
Yes.
we discussed several rounds and failed, and again. Finally, we actually combined together, and actually he is now getting a lot of interest in developing compact models for photonic devices. So he is doing a very good job. Actually, my colleague Professor Anjan Chakraborty, and he is also from Kolkata. He studied in radio physics, Calcutta
Okay.
University. Yeah. So and he was also there many years in Germany. I met him in Germany, and together we are developing also compact models for photonic devices, which can go for EPDA development, so-called electronic photonic design automation.
Like EDA, electronics device automation.
So now, because electronic photonic, you are co-integrating, right? So you need to simulate a complete circuit. So some part it is a electronics domain, some part in a photonics domain. And you
Compact models like BSIM. BSIM is also a compact model.
exactly like compact model be similar type of thing, so that what you can get entire you can use in a spice simulator for simulating electronics as well as photonics together. Yeah, and it's a
I know because Mridul was doing, my
I,
husband, and
I see.
and
Okay,
Tech Simplified TV. He is the founder of this.
I see.
So
Okay.
he is working in CKMIT lab. You know,
Oh,
Professor CKMIT from Kharagpur IIT.
when you was
He
graduated?
was in there in 2007. We passed out from MSc, and then till 2009. So
So
for 2 years he was there, and he was working on this BSIM model and all this. So spice is almost his specialization. Many spice, Q spice, LT spice, all of these things.
oh,
He's doing a series on LT spice now.
right,
So
right. Very,
that's why I know BSIM about compact modeling. Yes.
correct. Very good to know.
So you, sir, your this strategy of contribution of both side, that is very good. This
Yes.
partnership lasts for long. And so, what are big challenges? If you can mention any single challenge which is big challenge still yet to solve in Silicon Photonics, in
Yes.
simpler words.
Yes. No, no. Actually, there are many challenges.
Mm-hmm.
Actually, we are talking about quantum photonic processor, right? In a quantum photonic processor, you need very large scale integration. Okay.
Hmm.
And very large scale integration, one of the important component is phase shifter. Okay, thousands of phase shifters required, and those phase shifter are basically micro heaters. So those micro heater, basically you heat up locally and then you change the phase. That is called phase shifters or photonic
Okay.
integrated circuit function. So those phase shifters consumes a lot of power. Okay, so that is where we are working on, so that we can go for low power phase shifters instead of heater. If any alternative things can be done or not. There are many options are there, but currently that thermoptic phase shifters are robust technology. So foundries, you can fabricate them easily in foundry, but they are very power hungry. Okay, so that has to be replaced. Otherwise, scalability, all those type of things is very difficult. So we are also working with SilTerra, any alternative solution like aluminum nitride, also hybrid integration, lithium niobate hybrid integration, all those type of things we are working out, so that this thermoptic phase shifters can be actually replaced by low power phase shifters like piezoelectric phase shifters or electro-optic phase shifters, those type of things. That will come anyway. Right now it is a challenge because it has to be hybrid integration. A lot of opportunities there to develop also. We are working together with SilTerra. We have a roadmap on that.
Okay. So that
Yeah.
is also a big
That
challenge.
is a big challenge. And
So
another
what?
big challenge is packaging also. Packaging, another thing is that fiber attachment, whenever you bring optical fiber light from outside, because silicon cannot generate your laser, no? Sometimes laser
Hmm.
into the fiber. So that fiber attachment, when you do, the loss, coupling loss is relatively large. That coupling loss has to be reduced. That is the
Minimized.
second things, minimized. And also another third point I should mention, when you ask this question, I should complete entire story. So another thing is that when you go for large scale integration, and you will be working with quantum photonic application, for example, a single photon you generate, and that single photon need to travel entire circuit.
Hmm.
So anywhere you see defects, everything, there will be scattering losses. So that photon
Hmm.
can get lost also. So loss is a important. So waveguide loss has to be
Hmm.
reduced. So that is where currently the silicon photonics devices are being fabricated mostly in 180 nanometer or 90 nanometer technology nodes.
Hmm.
Whenever you can fabricate, even though photonic devices are a little bit large, but if you make, you fabricate them in lower technology node, then waveguide surface roughnesses, etc., will be reduced. Loss loss will be reduced. So that is another important aspect we need to solve. waveguide loss has to be reduced as well. So three things. Major challenge now. Major challenge means it is on the way in the process. One is waveguide loss reduction, and second thing is that low power phase shifters integration, and third thing is your packaging related things, so that fiber attachment, everything, coupling losses can be reduced. So these are the technology one need to improve, develop. Yeah.
So since you mentioned that photon will travel a long distance, when in conventional circuitry, the signal is traveling, it
Yeah.
loses its magnitude value. So repeaters or buffers are used. In this case, also photon is used. Repeater kind of thing is used in silicon photonics.
Actually, Silicon Photonics is very bad for, you mean to say amplifier, no? Inline amplifier. Silicon Photonics, chip scale amplifier or laser is not demonstrated yet. People demonstrated, but not yet streamlined in foundry. Okay, so that is the problem. But thing is that when you say that long distance, within the chip, long distance means we talk about centimeter. Longest maybe centimeter, 1 centimeter long. Chip size is centimeter, for example, right? So currently, waveguide losses are 0.1 dB to 1 dB per centimeter and so on. So that, in that sense, classical application point of view, that loss is not a big deal. But whenever talking about quantum photonics, you are dealing with photon by photon, right? So every photon is precious. Even 1 dB, 0.1 dB, even if you send 1,000 photons, out of them maybe 10% photon is lost, then you are gone. Okay, 10% loss, you have to lose also, right? So those things are very important. So whenever you are talking amplitude attenuation, and then you amplify, in quantum photonics, you cannot do that, because here you are working with a quantum state of a photon, right? And quantum state, you cannot just clone another quantum state. It is called no cloning theorem. Okay, so a quantum state cannot be reproduced, or maybe from one quantum state you cannot generate another photon with same quantum state. That is, we are talking about amplification. So that is quantum mechanically, that is actually not possible. Okay, so you have to work whatever your quantum or photons you are generating, everything you have to work with that only. No options are there to amplify. If you amplify, then quantum state gone. All the things are going. So that is actually a problem. That's why I was repeatedly talking about waveguide loss. If you are sending 1,000 photons, you cannot afford to lose maybe 10% photon, maybe 1 or 2 photon.
So reduction of, since amplification is not possible, controlling reader loss is important.
Yes.
Okay. So what is the long-term vision of CPPICS? Full-fledged production, development, and industry.
Yeah, I think one thing is that it should be in my target is that it should be an important center where you can support a lot of startups, our own research scholars, students. They should go out, they should do some kind of incubation, they should do business, because we want to, that is actually the missing part in India. We have to manufacture, we have to deep dive, and that is the thing. And this CPPICS can be a supply chain to them. For example, they can test it here, they can do they can work here. So it can be, it is actually kind of should appear as a national facility, so that a lot of lot of products should come out from this facility. And that is the long-term vision for the moment. But many applications, we have the roadmap, all those type of things. I cannot disclose everything here.
Sure.
That is
you must not, sir. We encourage not to disclose all these things. That's why we try to be in generalized area, because your domain, you are the expert.
Yes.
Not everyone has this depth of knowledge. Even your generalized discussion is heavy for many people. So we
Yeah.
are enriched with that.
Yeah.
Yes. So well,
So
it's
wherever
already a
you feel,
center of
okay,
excellence. Hope.
wherever you feel that it is something more technical things, if you want to remove, you can remove from the video.
No,
All this.
it's going as it is. So people will hear whatever you are saying, every word, bit by bit.
Okay.
No moderation or no editing.
Yes, I think you can ask your audience if they have any questions or to clarify things. Also,
Yes,
they can.
it's always there. Sometimes question comes, and I think today people are really the way you explained everything. It's very technical thing. People will get amazed, and
Okay.
gradually view
I
will
hope.
increase. Yes, if any question come below, we always request them to put question below
Correct.
the video. Obviously, we will redirect to these questions to you.
Okay.
And sir,
Okay.
finally, what's your message to young minds who are thinking to do research, entering electronics field?
Yeah. So I think the what I can say that to young generation, you mean to say young generation message, right? Yeah.
Yes, sir.
So I can only tell them that learn silicon photonics. So first thing is that you see, most of the time people think that photonics again. Many of the students also today's generation, they mostly go for AI, ML, this type of because a lot of jobs are there, particularly. But ultimately at the end of the day, to run those AI, ML, everything, you need a hardware, and
Hmm.
silicon photonics is a solution. Okay, so they must learn silicon photonics as much as possible, not only for only software coding, algorithm development, everything. Those are important, no doubt about it. But some manpower, some students should come forward, those who can actually deep dive and develop some hardware, which is actually very important for them. And yeah, because silicon photonics again, any discipline today you talk about, people are exploring everywhere. You can say that high speed communication in data center, so you can say that high speed low power, high performance computing, not only quantum, normal classical high performance computing also silicon photonics. And you can think of this 5G 6G, when your wireless communication going higher and higher frequency, so backhaul operations, everything, data handling, everything you need for silicon photonics. You need for edge computing, for IoT, all those type of things. They are also silicon photonics has a huge potential. And in my opinion, without silicon photonics, I think next generation technology is a very, very difficult. So silicon photonics technology and lots of job opportunity, particularly the research scholars, students work in my lab, they become highly employable. So young generation, first thing come to their mind is that whether I will be able to get a job or not. I must tell them that this is the area. If you work anywhere, you don't need to work only in CPPICS or something like that. There are many places now in India also. Silicon Photonics research started. I think ISC Bangalore also they started from 2015 onwards. We started in 2006, 2015 onwards. They have started Silicon Photonics, and many other places also, small and big. They've started working. So anywhere you get opportunity, I think this is one area. If you work, if you learn, and you will never be a jobless. You will be getting job, and plenty of job. Our research scholars are, our students are highly employable. I think retaining them also to do something like that. So I am thinking, I am trying to convince our government that we have to pay them also equivalently. Otherwise, they will be getting a lot of salary. You cannot just keep them all the time, because they need also money is required. Bread and butter. That is also important part. So that is very important. Job is there. I think, and learning silicon photonics is really amazing. Lot of open area, and if they can actually contribute a lot. in this particular area, because silicon photonics is completely a different beast than your electronics. They are only, if you are only transistor and then circuit. Here photonics not only transistor, many components and then circuit. So this is a challenging task also. Enjoy, they will be enjoying. So that is my things, that plenty of jobs are there and you will enjoy and learn silicon photonics. That is my message to young generation.
Yes. Another thing, sir, it's not like a device built in lab now need to get accepted in commercial industry. It's already been accepted in industry,
Yes,
and more research. So there is high scopes. So
yes.
there, I mean,
If you just search silicon photonics job now, plenty of jobs are there today. As today's scenarios, I think it is already accepted in the industry. Many industry, I think, in the last 5 years or 6 years, at least more than 2,000 startup company actually created worldwide. You know, besides your all the semiconductor giants, thousands of startup companies across the world. Even in India also, there are many startup already running, like Confluence, QPI. There are some
Cuba,
companies.
yeah.
uh,
Recently, I
uh,
saw that.
and so they are doing, I think, QNU Lab, all those type of things. They are doing something. I don't know how good they are performing, because ultimately many times I see that they are shortage of trained manpower, like silicon photonics knowledgeable things. People are mostly, the thing is, uh, uh, it is silicon photonics in semiconductor industry already there, but our traditional degrees, either electrical engineering or optical engineering or photonics or something like that. Those who know electronics, they don't know photonics, and those who know photonics, they don't know electronics. But silicon photonics is that where electronics and optics are actually marriage happens here. Actually, you need to
Both.
know, they are complementary. You need to know both sides. So I suggest that more and more engineering student, particularly electrical or electronics engineering student, they should work or study silicon photonics. Then this technology will grow faster. Okay,
Okay.
that's what I mean. I am blessed because I'm sitting in the electrical engineering department. So I also offer some UG courses, PG courses, so that the students also learn here from the beginning and they go forward. So that is what my message. Yeah.
Okay. So we had lot of questions, lot of technical discussions, and almost very new thing for me, and I think for many of our viewers. So we had
I hope.
really
Yeah. I
very
hope.
enjoyable session.
I hope I answered all your questions as you expected, and
Yes, 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 sir.
I think your questions are very apt. I think I like these questions. I think these are very
Thank you, sir.
important questions. All the audience should know. In India, silicon photonics, not as I mentioned, that some places are there, but not it is widespread yet. We should have actually hundreds of research groups should be there in this vast country, but unfortunately, because it is a kind of high-end technology, etc., not every place, even though a lot of experts are there, they are not really getting enough opportunity. I think government also look into all these things, because they recognize that silicon photonics is one of the important area, but funding also should be proportionally should be increased in this area. Not only
And
for IIT Madras, I think whole India should be, wherever we get talent,
more
everything.
labs will come up like
Yes.
CPPICS. More
Yeah, that.
research work should be channelized in this direction.
But channelized means not at the cost of reducing fund from CPICS. They should increase funds
No,
also.
no, no. Obviously not. The money should channel from not from civics but from central. One
Right.
thing, sir, this research and whatever scientists and professors like you who are doing work, not much highlighted. Some post we get to see, few people around you might know. I didn't had much idea. I first came to know from that iZMO electronics, that post, and then I connected with you and started to go through the website and came to know and thought, okay, let's talk with sir and try to understand what kind of work is. It's a center of excellence, we must know. And I think its time has come. Though we are progressing, we need to do many things. Already what we have achieved, we must be proud of it, we must celebrate that. Whatever we are doing, our people, our teachers, professors, what they are doing, we need to celebrate it, because
Correct.
more people will get encouraged that yes, our contribution is getting celebrated, acknowledged countrywide. And our community, it's something, there is not very much connectivity. Design houses one side, PDA one side, research on one side. We need to make a proper connection, because we are all working from this land, and we are working to make the future of this country better. So we have to be connected, we must celebrate each other's success and be proud what we have achieved, and then all together we will achieve more. That should be
Yeah,
our
yeah. I
motto.
think you are right that we should be. I think this is a good point that we should be connected. We should disseminate whatever happening, everything,
Mm,
should
yes.
know each other. Yeah, but I think one thing is that we should not make unnecessary noise also.
Yeah.
So we should be announcing, or if something really things comes up, so then announcement is better impact, otherwise people will not believe us also, you
Yeah.
know. So that is one things. Many times, you know, suddenly if you make a noise, you have done and you start making a noise, and then after sometimes it is not happening, then I think it is a negative impact. So
Mm,
I believe that I think whatever is, for example, I honestly, whatever I told, that is a fact. What I'm telling you, I think
mm,
it is something not exaggeration anything. So whatever we are doing, or nothing less also. I talk. So what is exact? That is what I try to portray here. So I think that is what we believe, and we should be connected. We should be telling people that whatever is happening, you are right. We should be doing, but it should be exact, not.
exactly.
Yeah. So yeah. Thank you
Okay,
very
sir.
much. Thank you very much. Yeah.
Thank you, sir. So we are done with our today's session. We had a very engaging technical session with Professor Bijoy Krishna Das from IIT Madras, and we have come to the end of this session. So thank you, viewers. Do follow Tech Simplified TV, and don't forget to watch the Semiconductor Podcast. Here we celebrate technology and people related to all this progress in our country and abroad. So thank you for staying up to this point. We will be back with another exciting episode. Till then, thank you and bye for
Thank
today.
you. Bye-bye.
Thank you, sir.